Hi there, welcome back. Welcome back to the channel. And this time I've got something completely different for you once again. This is in answer to quite a few questions that I've had in the recent past as regards something I've mentioned quite often, which is simplifying a schematic. Now, if you've watched some of my videos, some of them, I go into a lot of depth, a lot of detail into the schematic. And I've got this little habit of erasing stuff that I'm not interested in. And a lot of you have asked me about that. Now, something else I've been asked very, very often is what software I use to do the tracing and recording of what's been done and what hasn't been done. You know, all those little colored pictures that I show you? Well, I've mentioned that before. It's Adobe Reader. It's got a comment function. The comments can be text, or it can be lines, or it can be polygons, it can be whatever. That's what I use, and I've done a video on that, and I'll link that above and in the description below so you can look at that. But this is something different. This is really got to do with simplifying a mess that you see when you look at a schematic for a tube radio. And if you want to focus on a part of the radio that you've got to troubleshoot, or that's the part you're restoring, like I'm doing now with the Philips, I'm doing the AM section, you can actually make it a lot more understandable if you get rid of everything that you don't need. And the way to do that is actually very, very simple. It's a question of going onto the schematic and deleting or painting over that which is not pertinent for the part of the circuit that you're looking at. And to show you that, I'm going to show you what I do here on this particular radio, the B7X14A Philips. And this has got to do with the AM section that I'm working on now, so you'll be able to see exactly how it is that I do it. Now, bear in mind, I use software called Photoshop. I'm sure you've heard of it. There's actually a free version online, which is P, I think it's called. But you can use any software that allows you to paint on it, right? As long as you can put a layer on top and you can paint on it, whatever software you want to use, you can use it. The logic's the same. So I hope this serves some purpose for you. Hope it makes your life easier. It certainly made mine incredibly easier. So I'd like to share it with you. Hope you enjoyed the video. I've imported a copy of the schematic into Photoshop. And the first thing I do, I want to keep this schematic as original as possible. So the first thing I do is duplicate that layer. I'll hide the original one and we'll work just on the duplicate copy. So what am I going to do here? Well, I want to get rid of everything that does not have to do with AM. And specifically, I'm going to focus, for example, on shortwave reception of the AM, so we can see how that signal follows through. Now, that means that I need to look at the switch that has to do with shortwave, which is KG switch number 5. So switch number 5 is going to be the only one that changes state. And where is switch number 5 on the schematic? Well, I only see it in 4 places actually. There, 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 and there. But before I get into that, let me delete or hide everything that does not have to do with the AM bands first. And I can do that in one of two ways. I can actually delete it, or I can paint on it. And I prefer to paint on it because then I can delete what I've painted over. You'll see what I mean in a minute. I've got this original copy here, but I'm going to create another layer, and I'm going to work on this layer, and I'm going to paint it in white because that's my white background. And to paint, I'm going to use the paintbrush. Now I can change the size of the paintbrush, and I'll start with the main things first, like this at the top, and the switches themselves, the power supply, the amplifiers. And what am I looking for exactly? I'm actually looking for bringing in a signal at a point which will be here at the antenna. The signal will come in here. And what I'm looking for coming out of the AM section of the radio is AM audio. And I know, because this is the amplifier section here, I know that that signal, that audio output from the AM band that I've selected, and I've chosen to go for shortwave, that signal will come out here. In other words, it'll go through that capacitor to the audio section. So everything else that doesn't have to do with the signal coming to this point will be deleted. Let's get started. So what I'm left with now is just the radio stage, and I've actually got 2 sections here. One is the FM and one is the AM. I'm going to get rid of this thing, the main part of the FM, which is the FM box over here. So now our FM has completely disappeared from here, but it's also visible somewhere else. Let me show you. This section over here only has to do with the FM. It's the FM ratio detector. So I can actually get rid of that. And also, so I can get rid of all this to the right of this line here. But also this here, this tube here, as regards FM, which comes from that secondary of that IF transformer there, it comes in here. And all it's doing here, as regards FM, is being amplified and pushed through that primary of that IF transformer, which then gets induced on the secondary of that IF transformer. So all this can go as well. And that really is what we're left with, although we still have stuff here we don't need. So let's concentrate on what it is that we do need. We are looking for shortwave. So let's go to here. Now we know that our signal comes in from the antenna and ground over there, comes down here. It's shortwave, so it goes straight into there through that IF trap, which means that this section down here is not necessary. It comes down here to that switch, and shortwave is active, so this switch changes state, that switch changes state, that switch changes state, and that switch changes state. Now if this changes state, let's see what happens. So those two switches have changed state, and we can see now that this section down here is no longer pertinent. That disappears. If that disappears, we can just make this come here and across, straight across, right? There we go. And that's no longer a switch, so if we really want to get detailed on here, we can just delete that. And just to make it clearer, let's get rid of that as well. We've already activated it. So what we've got here is the signals coming through the IF trap, into there, through this transformer here. This is the primary, and it induces the signal on this secondary, and this secondary is part of a tank circuit which comprises this inductor, this small capacitor, this small trimmer capacitor, and if we follow this line to here, it also catches the one section of that tuning cap. But we need to get rid of this, right? Because that's not part of the circuit anymore. Now it's all nice, and we can go one step further. If we're going to get rid of anything superfluous, that switch has been activated, and we've got this whole section here which is no longer necessary. It's completely out of circuit. This has to do with the long wave and medium wave. Brilliant, it's nice and clean. Now, as I said, we've got a tank circuit here which includes one inductor, one small cap, one trimmer cap, and one variable capacitor. The top of that is the resonant point, or the output of that resonant circuit, and it comes along here to there, down to here to a switch which is no longer part of our thinking because it stays the same, along here and up to there. So we can just bring it across here and eliminate that section. Just makes it simpler. Nice. A very simple tank circuit at the front end, pre-tuning to the band, or the part of the band, in this case shortwave, created by this tank circuit here and adjusted by this one section of the tuning capacitor. Right, now we go to the oscillator section. Just while we're at it, I'm being really pedantic here, but I'm going to get rid of all this text that is no longer necessary. There we go. So what happens on this side? This is the oscillator section, and we know that switch 5 changes state. If switch 5 changes state, what we're getting is this here makes, that there makes, And that there breaks. That there breaks. Okay? Now we've got sections here that are totally flying around with no purpose whatsoever. We've now made those two switches, so let's get rid of this. And we can get rid of all this down here. Voila. What do we have on this side? We've got a tank circuit, another tank circuit here, which is tuned by this section of the tuning capacitor. And that is creating the frequency, the oscillator frequency, local oscillator frequency, which is exactly 452 kilohertz, higher than whatever that circuit tunes to. And that is the principle of a superhead receiver. And we can now see it a lot more clearly. There's one more bit here that's not necessary. That is this line down here. Done. Done. So our input frequency is selected. Our local oscillator frequency is selected. The difference shoots out of here, out of the anode of the mixer tube, and it goes up to here. And now what happens here? These two here, this is the IF transformer for the AM, primary and secondary. This has to do with FM, primary and secondary. And we know that for the frequencies that are related to the AM, in other words, 452 kilohertz, these guys are invisible. In fact, this one's actually shorted out until FM is activated. So we can actually get rid of this part of the circuit that doesn't relate to the AM. And how do we do that? Well, if we take this line going across here, goes through there, through there, through there, up to here, and it comes across to this point, and that disappears. So let's do that. There we go. The other thing we know is that on this side, this transformer has no purpose whatsoever, so we can just short this across there. It's like a short circuit. And we've simplified it again. Now we go to this section here. So what has to do with AM? Well, the IF frequency signal comes in here, gets into there. All that is necessary. It gets amplified, comes out here, goes through the FM section, which, as we've said, has absolutely no purpose whatsoever on AM. So these will disappear. And it gets through to our secondary here for the on the AM IF transformer, and it goes into the grid, or rather into this diode on this EBF89. So that can actually be got rid of as well. Let's do that. There we go. What else do we have here? We've got this switch, which is switching in the audio from, where is it from? Well, it comes from here, from the diode, which is detecting the AM, and this is through the coil. That's basically audio coming in here with some RF. The RF gets bled off to ground. So this signal coming on here is actually the audio on a DC voltage, which is the AGC. That there goes to this point, which then comes out of the audio selector switch, input selector switch, for allowing the AM to come through as audio. Audio comes out here, goes to the audio section, which we know is working. The DC component of that rectified signal over here, that comprises a DC component, which is a negative voltage, which is now our well, it's actually the AGC voltage. It's a voltage that is negative, and the extent that it is negative represents the signal strength. So the stronger the signal, the more negative it is, and that sends this back to this capacitor here, which smooths it a bit, gives it a bit of a longer time constant, and that then gets fed to the grids of the previous two tubes. to control their gain. The more negative voltage it goes up there, the lower the gain of this tube, because it goes up there, it's DC, so it goes through that coil there into the grid, and that controls the gain of this tube. And similarly, it comes out of here, goes through that 1.2 meg resistor into the grid of the mixer tube, so it again changes the gain of that tube. So we have to leave that there. This here stays as is because it's giving us, this is the magic eye. It's going to give us the, well, there we go. It comes from that AGC voltage across there, through there, into our magic eye, which will give us a reading or a deviation depending on how strong that signal is. In other words, how strong that negative voltage is. So all this is now our AM circuit for shortwave. Now, doesn't that look simple? Once you've got the circuit into this format, it is very, very simple to troubleshoot it. You actually have a very small circuit to troubleshoot. And this is the purpose of my exercise in reducing the schematics so that I can get them into a state or into a form that would make it very, very easy to troubleshoot. In this case, I would select AM, well, I would select shortwave, and I'd be able to troubleshoot this thing quite easily because there's not all the rest of the clutter on here. Mind you, finding these different components on the radio still means that all the other components are floating around, albeit isolated, as you can see from the schematic. They're still there. It just makes it incredibly simple to understand how the radio works as regards shortwave in this case. If you wanted to go for long wave, you would do exactly the same exercise, except you would activate the switches in a certain way to get rid of the things that aren't pertinent. That's how I do it. Okay, I hope that's answered the questions of quite a few of you that actually emailed me asking me how I do this. Now you know, no more secrets. So I hope this information proves useful to you. Hope it makes your life easier. It certainly helped me an enormous amount. And if you've enjoyed that, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Once again, thanks for watching. Bye for now and stay safe.